It's time to talk about steering behaviors. I've started every video in this series so far with this simulation running in the background. These ships are using several steering behaviors all at once to move around in what I think at least is a fairly nice and realistic way. And this is what steering behaviors really provide, far more realistic movement. And they provide this realistic movement by applying forces to an object, very much like a physics simulation. And just like a physics simulation, part of what makes steering behaviors so useful for providing this realistic movement is that you can add and layer forces together to get some really complex behavior through some very simple rules. Unlike a physics simulation though, the idea behind steering behaviors is that each behavior is a want or a desire of the object itself that the object is acting on. So in a sense, the forces are internal rather than external. In the case of the simulation you see running here, each ship has 3 desires. Each ship wants to fly roughly in the same direction of the other ships near them, get closer to other ships, but also avoid being too close to these other ships. Just those 3 things. In fact, the step event for each ship looks like this. And each of these 3 steering behaviors is represented by a single function. These 3 lines get the 3 forces that the ship wants to act upon. Now, we're not going to go over this code in this tutorial. In fact, this is from my own separate project that I use to prepare for these tutorials, but we will get to it down the road. But in this tutorial, we are going to create 2 steering behaviors, seek and flee. And we're going to create the following simulation. Here we have a ship that is seeking the mouse, or if I push spacebar, flees the mouse. But before we get to these actual steering behaviors, the forces themselves, first we have to cover this fundamental idea of applying forces to our objects. The first key idea to understanding how we apply forces to our ships is that our ship's future position is equal to its current position plus its velocity. So our ship's position is an x and a y, which seems a lot like a vector. In fact, we can imagine that our ship's position is a vector from the origin point of our room. And if our ship's position is a vector and our velocity is a vector, we can add these 2 vectors together and get our ship's new position. This new vector is our ship's new position. The new position is the current position plus the velocity. And if we break it down a little bit, that should make sense. After all, if our ship's x position is 100 and the x component of our velocity is 5, 100 plus 5 is 105. And of course, the same would also be true for the y value. And you've probably programmed this many times. If you've ever typed something like x plus equals h speed or y plus equals v speed, that's the same concept. Except now, instead of having an x and an h speed and a y and a v speed, we've collapsed those ideas into position and velocity. But if you think about it, position is just a combination of your x and your y, and velocity is just a combination of your h speed and your v speed. So that's the first thing. Our next position equals our current position plus our current velocity. The second thing is this idea of adding forces together. Since our forces are vectors, adding forces together is the same as adding vectors together. And we have 2 primary types of forces that we're going to be using. The first is our velocity. This is a force that will maintain its value from frame to frame. The second force, though, we'll call steering forces. Steering forces is a collection for all the various steering forces that act on our ship in any given frame. And the frame part is important. We need to remember to zero out the steering forces every step. So throughout the step, we will collect various steering forces and we'll add them together. These forces will be all the different desires the ship has that step. Then we will add this collection of steering forces to our velocity and add our velocity to our position. And that is how our ship will move. All of the steering forces get added up, add that result to velocity, and add our velocity to our position. So now let's see how this is implemented in code. First, for our ship's create event, we now have 3 vectors: position, velocity, and steering forces. And when we create our position vector, we're passing in our ship's x and y. We also have the variables max speed and max force. These are the 2 variables that we'll use to limit and tune our ship's steering behaviors to achieve the type of movement that we want. By changing these 2 values, we can change how our ship moves about. Do we want it to be fast or slow? Do we want it to be able to turn quickly or slowly? That's what these variables will allow you to tweak. And then in the step event, we're going to add our velocity to our position, just as we did before, and we're going to keep the limit in. There are other ways to do this. For example, you could introduce friction or drag to prevent velocity from continually increasing, but limiting it is good enough for now. Next, we are going to add our velocity to our position. Remember that our current position plus our velocity will give us our new position. And finally, we need to remember to zero out our steering forces. And this is really all we need to handle our steering behaviors, outside of the behaviors themselves, of course. But now that position is a vector, we do need to manually update our x and y. This, unfortunately, is just a quirk of the fact that GameMaker has built-in variables for x and y. You don't need to use them at all if you don't want to. You could go into the draw event and manually draw the ship's sprite at position.x and position.y. But since the default drawing options and all of the collision functions use the ship's built-in x and y, it's easier to just manually update them, in my opinion. So we will update these values and then get our ship's image angle by using velocity.getDirection. So this section right here updates all of our vectors, and then we have this section which takes that information and updates the built-in GameMaker variables, and now our ship is set up, and the only thing that remains is to create our first steering behaviors. The goal of every steering behavior is to return some steering force. For seeking, we calculate that force by going through the following steps. First, we figure out the direction our ship wants to go. To do this, we are going to subtract our current position from our target position. And this might seem a little bit weird, but it turns out that if you subtract one vector from another, you get a third vector which points from the end of the first vector to the end of the second. Honestly, I still struggle with this concept, but it really does make sense. So if we take this vector of 2, 3, and subtract it from this vector of 5, 4, we get this new vector of 3, 1, which is the vector that points from the first vector towards the second. But if this doesn't make sense, then it also works to just memorize that if we subtract vector A from vector B, the result is a vector which points from the end of vector A to the end of vector B. Or in our case, target minus position gives us a vector from our position to our target. In other words, the direction our ship wants to go. Now, we take this vector and set it to max speed. This gives us our desired velocity. But we already have a current velocity, and our goal is not just to set our current velocity to our desired velocity, but to provide a steering force that moves our current velocity towards our desired velocity. And we can do this by basically repeating the first two steps. We can subtract our current velocity from our desired velocity to get a new vector that points from our current velocity to our desired velocity. But again, our goal is not to instantly change our velocity. So the final step is to limit this vector by max force, the max amount that we allow the steering force to be. And the result of this final limitation is our steering force. So to recap, we get the vector from our current position to our target position, set it to max speed, and this is our desired velocity. Then we get the vector from our current velocity to our desired velocity and limit it by max force, and this final vector is our steering force. And hopefully this does make some sense. If our ship is going this way and it wants to go this way, then a force which pushes it this way will steer it towards its target. But it is a complicated subject, and as I've said before, often with complicated subjects, it helps to hear it explained by multiple people. So if what I've said hasn't made sense, I'm not offended, and I recommend either watching these videos from the Coding Train channel or reading this blog series. Fortunately though, the code for this is almost exactly what we've just described, except that we have one additional step. Since we want to be able to seek things that might not have a position vector, such as the mouse, we're going to pass in our target's position as an x and a y, and then turn it into a vector, which we're doing with this line here. But after that, the first step is vector subtract position, or target minus position, then vector set magnitude, max speed, then vector subtract velocity, then vector limit magnitude, max force, and finally we return the vector. So the exact 4 steps we just walked through conceptually, we can represent in code pretty much thought for thought. Now we can come over to our ship's step event and write steering forces.add seek force mouse x and mouse y. So we call our steering behavior and we get a steering force back from it, which we add to our steering forces variable. Now we only have one steering force here, so technically we could set our steering force to this force. But what is so powerful about steering behaviors is that you can add them together. We're not doing that yet, but we will, and so that's why we're using add rather than set. Now we can run this, and we have our seek behavior. Next, we can add our flee behavior, which we get pretty much for free because the only difference between seeking and fleeing is the direction you're moving towards the target. For seeking, we move towards, and for fleeing, we move away. So all we have to do to get the flee force is flip our initial desired velocity. So we get our desired velocity and then we negate it. In code, all we have to do is add vector negate right here. And that's it. Everything else will work exactly as before. Now we can come over to our step event, add in the keyboard check, add in steering forces.add flee force, mouse X and mouse Y, else steering force.add seek force, mouse X and mouse Y. Then we can run it, and we have a ship that both seeks and flees. The source code for all of this is linked below if you want to experiment with it, and in the next tutorial we're going to add the steering behaviors pursue, avoid, arrive, and leave, and we'll also start to experiment with adding steering forces together. And once that video is up, there'll be a link to it in the top right.